What makes something random? Hi, welcome to Curious Kids Every Day. I'm Josh. How are you doing today? It's so good to hear from you. Hey, have you ever heard someone say, "Whoa, that was random"? Have you ever thought about that word? Random? Do you know what it means? It's actually a very interesting word with a lot of interesting questions attached to it. Well, the word random is defined like this: having no specific pattern or purpose or objective. That just means that you have no way of guessing that something is going to happen. Kind of like rolling a die. Do you like to roll dice? Can you guess what the number is going to be before you roll a die? You might accidentally get it right sometimes, but you never know for sure what any one die roll is going to be. So, it's kind of random. Except, it's kind of not random too. Did you know that you actually, kind of, sort of, can guess the roll of a die? It's not completely random. See, a lot of things that seem random actually aren't. Do you want to learn about it today? All right, imagine you roll a normal 6-sided die. Can you predict exactly what number it will land on every time? Of course not. It might be a 1, 2, 3, 4, 5, or 6. You might get it right once or twice in a row, but over and over? No way. It feels very random. But even though you can't predict one roll, there is something you can predict. See, a die gives each number an equal chance of appearing. And that just means that every time you roll a 6-sided die, there's an equal chance that it will come up 1, or 2, or 3, or 4, or 5, or 6. If the die is made correctly, there's no one side that's going to appear more than the others. There's an equal chance for each of the 6 sides. So that means that if you rolled a die hundreds or thousands of times, you can expect that each number will show up about the same amount. You can try this at home. Try to roll a die 100 times, and as you do it, write down how many times you get 1, 2, 3, 4, 5, and 6. It's not going to be exactly equal for each number, but it's going to be a little closer than you'd think. So even in randomness, there is order. Individual events can be unpredictable, but large groups of events often follow patterns that mathematicians, and even just you at home with a pencil and paper, you can predict them. So not all things that look random are completely random. And there are some things that seem random that actually aren't random at all. It's a trick. Let me give you a cool example of that. See, the other day, my boys were wondering how video games can have random things happen within the game. Have you ever been playing a video game where maybe a treasure chest appears at random spots on the map, and every time you play, they're in different locations? Or perhaps you're fighting an enemy, and that enemy moves differently every time you play, so you can never guess what they're going to do next. Or maybe a game gives you a prize, and you can't guess what that prize is going to be each time. All of those things feel very random, don't they? But computers have a problem. See, computer programs are extremely good at following instructions. In fact, that's all a computer program is. A computer program just follows instructions over and over again. They never think. They don't have independent thoughts. They do exactly what they are programmed to do. That's why they're called programs. When you're playing a video game, it's really just a computer program, following a bunch of directions. So how can a computer create something random? Like, how can a computer decide to place a treasure chest in a random spot on a map? Well, the secret is, it's not actually random at all. Think about it. If I ask you to think of a random number between 1 and 1,000,000, you're going to pick some number that I would never be able to guess on the first try. Well, okay, I guess I could guess it on the first try, but there's a 1 in 1,000,000 chance that I'd get it right on the first try. Virtually impossible. That's because you're using your brain to pick a number. But computers, they don't have brains the way we do. They just follow instructions that they're given. So is it possible to ask a computer to pick a number at random? No. See, you'd basically be writing code that says, okay, computer, when I ask you to think of a number, just think of a number. But computers don't think. They can only follow instructions. So you have to give the computer directions. But when you tell a computer how to pick a number, well, the number's not random anymore, is it? So a computer program by itself can't just invent true randomness. It has to get its numbers from somewhere. So how do they do it? Well, computer programmers came up with something called a seed. A seed is simply a starting number. The computer takes that number and runs it through a series of calculations that create new numbers that appear random. But how do they come up with that number? Well, sometimes the seed comes from the current time, because the current time is always changing. Yep, computer programs use clocks. Since the exact moment that you click a button or start a game is usually different every time, the program starts from a different place and creates a different sequence of numbers to calculate randomness. But it's not actually called randomness. It's called something else. I'll tell you in a minute. Now, it's more complicated than I'm going to explain here, but I want to give you an example so that you can kind of just understand this idea. Let's say you get to the end of a level in a video game you're playing, and you get to open a treasure chest. Maybe you're gonna get either a sword, or a shield, or some health. And you never know which one of those three things it's going to be. A sword, a shield, or some health. It seems random every time, but it's not. The game is faking it. Here's a very simplified version of what a computer program might be doing when you think it's choosing randomly. When you click to open the treasure chest, the video game checks what time it is. Maybe it's 12:35, and maybe the game is set up so that anytime the minutes on the clock are 3:05, you get a sword. But when the minutes are 3:36, so like if it was 12:36 p.m., you get a shield. It feels random, but it's actually all dependent on what time it is. Again, it's much more complicated than that, but I just wanted to give you a general idea of how a computer program makes the numbers look random to us, while the computer is still really just following instructions that it's been given. Scientists call this pseudo-random. Can you say pseudo-random? The word pseudo means something that looks like the real thing, but isn't exactly the same. It's not really random, but it works for what a game is trying to do. For video games, pseudo-random is perfectly fine. The result feels random to the player, and that's all that matters. Now, in researching for this episode, I discovered that true randomness in nature is actually really hard to find. And the randomness we can observe may just follow patterns that we don't quite understand yet. For example, do you know what an atom is? An atom is the basic building block of an element. The teeny tiny building blocks of everything around us. And some atoms are unstable. Do you know what that means? That means that at some point, they will change into a different kind of atom. Scientists call this radioactive decay. Can you say radioactive decay? So if you had a huge group of these atoms, scientists could make pretty good predictions about how many of them would decay over a certain amount of time. But here's the strange thing. If you pick just one atom and you look specifically at that one and you asked, when will this atom decay? Scientists can't tell you. It might happen in a minute, it might happen tomorrow, it might happen years from now. Some scientists think the exact moment is truly random. But other scientists, they're not so sure. Scientists agree on the probabilities. The debate is whether there's some reason we just don't understand yet that explains why and when an individual atom decays. It looks like true randomness, but is it really? I think it's so cool that we don't know yet. We still have more to discover about how our world works. And for as much as we know, there's still so much we don't know. Maybe when you grow up, you'll be the one to figure out how radioactive decay works. Until then, we'll just keep asking questions and staying curious. Okay, let's have a quick quiz and see what we learned today. What is the name for a number that a computer program uses as a starting point when it's creating pseudo-random numbers? Here's a hint. It's something you put into the ground to grow things. It's called a seed. And I already used the word in the last question, but what word do scientists use for numbers that look random but are created by a computer following instructions? It's called pseudo-random. And what is the name of the process where an unstable atom changes into a different kind of atom? It's called radioactive decay. Let's play true or false. True or false, a computer can pick a random number the same way that humans can. Nope, that's false. It's got to get its information and instructions from somewhere. True or false, a 6-sided die gives each of the 6 numbers an equal chance of appearing. That is true. True or false, scientists can predict exactly when a particular radioactive atom will decay. That is false. Would you rather roll a giant die 1,000 times or design your own video game? I have always wanted to design my own video game, but I never quite learned how to code. I learned a little bit about coding languages. I learned enough to know that I didn't know very much, but I'd love to do it one day. Do you have something like that you've always wanted to learn more about, but you've just never made the time to do it? All right, let's play a round of What Am I? What am I? I am often used in board games. I usually have 6 sides, and people roll me to determine what happens next. What am I? I am a die. Let's do another what am I? What am I? I am a starting value. Computer programs often use me when creating pseudo-random numbers. Sometimes I come from the current time on a clock. What am I? I am a seed. Oh, if you want another experiment that you can try at home, try this. Get yourself a pencil and a piece of paper and find a coin that you can flip. Flip that coin 100 times and write down how many times you get heads and how many times you get tails. Now, it won't be quite 50-50, at least probably not, but it will be a lot more equal than you might expect. Isn't that so cool how that works? Usually when someone says something silly or something strange happens, someone will say, "That was random." But now we know it's really not random. Maybe you didn't know someone else was going to say something silly, but the person that said something silly, they knew they were going to say something silly. They decided in their brain to do it. And because of that, it wasn't actually random. If I started making random gibberish noises, blah, 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 that's actually not random either, because I decided to make those noises. You weren't expecting it, but I knew that I was going to do it. And so I did it. Blah, 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 blah. What kind of question do you think we'll ask tomorrow on Curious Kids Every Day? I can't wait to find out. So until then, keep asking questions and stay curious, kids. And we've got some birthdays today. Today is Miles' birthday. Miles is from California, and Miles is turning 5. Happy birthday, Miles. Juliana is from Ossining, and Juliana is turning 5. Happy birthday, Juliana. Asher is from New Jersey, and Asher is turning 4. Happy birthday, Asher. Jake is from Iowa, and Jake is turning 6. Happy birthday, Jake. Charlie is from Georgia, and Charlie is turning 6. Happy birthday, Charlie. Owen and Elliot are twins from New Hampshire, and they are turning 4 today. Happy birthday, Owen and Elliot. Henry is from New York, and Henry is turning 6. Happy birthday, Henry. Alice is from California, and Alice is turning 6. Happy birthday, Alice. Anna is from Ohio, and Anna is turning 5. Happy birthday, Anna. Samuel is from Louisiana, and Samuel is turning 7. Happy birthday, Samuel. Neil is from Indiana, and Neil is turning 6. Happy birthday, Neil. Audubon is from Illinois, and Audubon is turning 6. Happy birthday, Audubon. Kian is from Pretoria, South Africa, and Kian is turning 7. Happy birthday, Kian. Tyler is from Virginia, and Tyler is turning 6 this week. Happy birthday, Tyler. Adam is from Texas, and Adam is turning 6 this week. Happy birthday, Adam. Archer is from Texas, and Archer is turning 3 this week. Happy birthday, Archer. Marlo is from Ohio, and Marlo is turning 5. Happy birthday, Marlo. And John is from Toronto, Canada, and John is turning 5. Happy birthday, John. To all the grown-ups listening, if your curious kid wants their birthday mentioned on the show, please visit supportcuriouskids.com and join the Curious Kids Club. That's supportcuriouskids.com. See you tomorrow.